Water spilling onto an electric baseboard heater poses a significant safety risk and can potentially lead to an electrical fire. Should this occur, it's critical to immediately unplug the heater, ensuring you don't touch the heater itself or any water in its vicinity. Then proceed to turn off the power to the heater at the breaker panel. Following these steps, it is essential to contact an electrician to thoroughly inspect the heater, verifying that it is safe for future use. Bathrooms are recognized as high-risk environments for electrical hazards, primarily due to the presence of water and electrical appliances. Because of this inherent risk, the National Electrical Code mandates GFI protection for all electrical outlets in bathrooms. GFI outlets are specifically engineered to trip and interrupt the power supply upon detecting an electrical leak, acting as a crucial safety measure to prevent electrical shocks and fires. GFI breakers are available for both 120-volt and 220-volt circuits. These breakers function by consistently monitoring the electrical current that flows through the circuit. If a discrepancy is detected between the current entering the circuit and the current returning from it, the GFI breaker is designed to trip, immediately cutting off the power supply. A 220-volt GFI breaker operates with a current transformer that meticulously monitors the current flowing through the circuit. In the event that the current flowing to the circuit differs from the current returning, the current transformer promptly signals the GFI breaker. Subsequently, the GFI breaker trips, effectively shutting down the power to the circuit. When it comes to installing a 220-volt GFI breaker, the process shares similarities with installing a 120-volt GFI breaker. However, several key considerations must be taken into account. Firstly, it's imperative to use a double-pole GFI breaker. Secondly, the white wire from the circuit needs to be connected to the neutral terminal on the GFI breaker. Thirdly, both the black and red wires from the circuit should be connected to the line terminals on the GFI breaker. After the GFI breaker is installed, it's crucial to perform a test to confirm its proper functionality. This can be done by plugging a lamp into the outlet and switching it on. Then press the test button located on the GFI breaker. The lamp should immediately turn off. If the lamp remains on, it indicates that the GFI breaker is not functioning as intended and it's necessary to engage a qualified electrician to replace it. When discussing electrical safety in the context of bathrooms, it's important to elaborate on the specific requirements and recommendations outlined by the National Electrical Code, NEC, and other relevant safety standards. The NEC provides comprehensive guidelines for electrical installations in residential, commercial, and industrial settings, with specific provisions addressing the unique hazards present in bathrooms. These hazards include increased exposure to water, humidity, and the potential for contact with grounded surfaces, all of which elevate the risk of electrical shock. GFI protection is a cornerstone of bathroom electrical safety, designed to mitigate the risk of electrical shock by quickly interrupting the flow of electricity in the event of a ground fault. A ground fault occurs when electrical current deviates from its intended path and flows through an unintended conductor, such as a person's body. GFI devices, whether outlets or breakers, are engineered to detect even small imbalances in current and trip within milliseconds, effectively preventing serious injury or death. The NEC mandates GFI protection for all 125-volt, 15-amp and 20-amp receptacles installed in bathrooms. This requirement extends to receptacles located within a certain distance of sinks, showers, and other water sources. The rationale behind this requirement is to provide an additional layer of protection against electrical shock in areas where the risk is highest. In addition to GFI protection for receptacles, the NEC also addresses the grounding and bonding of electrical equipment in bathrooms. Grounding provides a low-impedance path for fault current to flow back to the electrical source, allowing the overcurrent protection device, such as a circuit breaker, to trip and clear the fault. Bonding involves connecting all metal parts of electrical equipment and appliances to the grounding system, ensuring that they are at the same electrical potential and minimizing the risk of shock. The NEC also includes specific requirements for the installation of lighting fixtures in bathrooms. Lighting fixtures must be located in accordance with minimum clearance distances from bathtubs and showers to prevent contact with water. Enclosed and gasketed fixtures are often required in wet locations to protect against moisture ingress. When it comes to electric baseboard heaters, the NEC does not typically require GFI protection for permanently installed electric heaters in bathrooms. However, there are exceptions to this rule depending on the specific installation conditions and local codes. For example, if the electric heater is located within a certain distance of a water source or if it is subject to physical damage, GFI protection may be required. It's important to consult with a qualified electrician and local building codes to determine the specific requirements for electric heaters in bathrooms. While GFI protection is not always required for electric heaters, it is generally recommended as an additional safety measure. GFI protection can help protect against electrical shock in the event of a ground fault, regardless of the type of electrical equipment. If you are considering adding GFI protection to an existing electric heater circuit, it's important to use a GFI breaker that is specifically designed for use with electric heaters. Standard GFI breakers may trip unnecessarily due to the normal operating characteristics of electric heaters. In addition to GFI protection, there are other safety precautions that can be taken to minimize the risk of electrical hazards in bathrooms. These include avoiding the use of extension cords, keeping electrical appliances away from water, and regularly inspecting electrical cords and plugs for damage. If you notice any signs of electrical problems, such as flickering lights, sparking outlets, or a burning smell, it's important to contact a qualified electrician immediately. When installing a 220-volt GFI breaker, it's essential to follow all manufacturers' instructions and local electrical codes. The installation process typically involves removing the existing breaker, connecting the wires to the new GFI breaker, and testing the breaker to ensure that it is working properly. It's important to turn off the power to the circuit before starting any electrical work and to use appropriate safety equipment such as insulated gloves and safety glasses. If you are not comfortable performing electrical work yourself, it's best to hire a qualified electrician to do the job. A qualified electrician has the knowledge, skills, and experience to install electrical equipment safely and correctly. They can also ensure that your electrical system meets all applicable codes and standards. In addition to installing GFI protection and following other safety precautions, it's also important to educate yourself and your family about electrical safety. This includes teaching children about the dangers of electricity and how to avoid electrical hazards. It also includes regularly testing GFI devices and replacing them if they are not working properly. By taking these steps, you can help create a safer home environment for yourself and your family. Moreover, understanding the nuances of 220-volt GFI breakers extends to their specific applications and benefits in various electrical systems. Unlike their 120-volt counterparts, 220-volt GFI breakers are often employed in circuits powering high-demand appliances such as electric stoves, water heaters, and air conditioners. These appliances, due to their higher voltage and current requirements, pose a greater risk of electrical shock if a ground fault occurs. A 220-volt GFI breaker functions by continuously monitoring the current balance between the two hot wires of the circuit. In a normal, balanced circuit, the current flowing through each wire should be equal. However, if a ground fault occurs, some of the current will divert from its intended path and flow to ground. This imbalance in current is detected by the GFI breaker, which then trips and interrupts the power supply to the circuit. The tripping mechanism in a 220-volt GFI breaker is similar to that of a 120-volt GFI breaker. It typically involves a differential transformer that senses the current imbalance and a solid-state circuit that actuates the tripping mechanism. The breaker is designed to trip within milliseconds of detecting a ground fault, providing rapid protection against electrical shock. Installing a 220-volt GFI breaker requires careful attention to wiring and safety procedures. It's essential to identify the correct wires and terminals and to ensure that all connections are secure. The breaker must be properly sized for the circuit and the load it will be serving. In addition, it's important to test the breaker after installation to verify that it is working correctly. The testing process typically involves pressing the test button on the breaker and verifying that the circuit is energized. If the breaker does not trip when the test button is pressed, it may be defective and should be replaced. Another important consideration when installing a 220-volt GFI breaker is the type of wiring used in the circuit. The wiring must be properly sized and insulated to handle the voltage and current requirements of the circuit. In addition, the wiring must be protected from physical damage and moisture. If the wiring is not in good condition, it may need to be replaced before installing the GFI breaker. Furthermore, understanding the specific applications and benefits of GFI protection in bathrooms requires a deeper dive into the potential hazards present in these environments. Bathrooms are inherently wet environments, with water readily available from sinks, showers, and bathtubs. Water is an excellent conductor of electricity, which means that it can significantly increase the risk of electrical shock. In addition to water, bathrooms often contain grounded metal surfaces, such as pipes, faucets, and towel racks. These surfaces can provide a path for electrical current to flow through a person's body if they come into contact with a live wire. The combination of water and grounded surfaces creates a high-risk environment for electrical shock. GFI protection is designed to mitigate this risk by quickly interrupting the flow of electricity in the event of a ground fault. A ground fault can occur if a live wire comes into contact with a grounded surface or with a person's body. If this happens, the electrical current will flow through the person's body, causing an electrical shock. A GFI device is designed to detect even small imbalances in current and trip within milliseconds, preventing serious injury or death. In addition to protecting against electrical shock, GFI protection can also help prevent electrical fires. A ground fault can cause electrical current to flow through unintended paths, which can generate heat and ignite nearby materials. GFI devices can detect these ground faults and interrupt the flow of electricity, preventing fires from starting. The NEC mandates GFI protection for all 125-volt, 15-amp and 20-amp receptacles installed in bathrooms. This requirement applies to receptacles located within a certain distance of sinks, showers, and other water sources. The rationale behind this requirement is to provide an additional layer of protection against electrical shock in areas where the risk is highest. In addition to receptacles, the NEC also requires GFI protection for certain other electrical equipment in bathrooms, such as lighting fixtures and exhaust fans. These requirements vary depending on the specific installation conditions and local codes. It's important to consult with a qualified electrician and local building codes to determine the specific requirements for GFI protection in bathrooms. When it comes to selecting GFI devices for bathrooms, there are several factors to consider. These include the voltage and current rating of the device, the type of device, and the location where it will be installed. GFI devices are available in several different types, including receptacles, circuit breakers, and portable GFI adapters. Receptacle GFI devices are designed to replace standard electrical receptacles and provide GFI protection at the point of use. Circuit breaker GFI devices are designed to replace standard circuit breakers in the electrical panel and provide GFI protection for the entire circuit. Portable GFI adapters are designed to plug into standard electrical receptacles and provide GFI protection for appliances that are plugged into the adapter. The type of GFI device that is best suited for a particular application depends on the specific needs and requirements of the installation.